look at my snake in the snake game. It has to catch all the food as earlier, but I also notice that there is this green color wall kind of thing, which let me just try to see what happens if I go and touch. Oops, I end the game. It says dang because that was an obstacle. Welcome back, friends. We are looking at enhancing the Hungry Traveling Snake project from the WiByte Python curriculum available at www.wibyte.in. In this video, we see in a step-by-step manner how we can create an obstacle of this sort and implement this. The idea is not hard. This could be let's say a bad patch or a wall. It could have a more fancy shape as well. As you can imagine, we are going to create a new turtle to play this role. The steps that we are going to follow: one, we are going to create a turtle, make it large. We are going to make sure that the obstacle stays fully inside the playing area. Now, this is important. Assuming you're building a playing area, we will make sure that no food goes and falls on top of the obstacle. Now, obviously, this is important because if the food goes and falls on top of the obstacle, then it cannot be eaten. We'll also notice that t.distance alone won't work because the shape of the obstacle is such, and we cannot use it to determine if the snake head is touching the obstacle, and we will see how we can enhance it. Now remember, this is our equivalent to saying touching sprite. In fact, we'll kind of build a little bit more to this to kind of emulate the touching sprite behavior. So let's see this one by one. Starting from, let's say, creating the turtle. Now this part is easy. We will create a turtle to become like the obstacle here. We will keep track of what we call the bounding box. Now this term may sound a little fancy, but really all we mean is a rectangle that can hold the entire turtle. For example, in the obstacle case that I just showed you, the obstacle itself was a rectangle, and hence the bounding box is exactly same as the turtle. In case my obstacle is, let's say, shaped in a bit more fancy manner, for example, I made it a parallelogram over here. Again, the bounding box remains exactly the same as earlier because all I'm saying is that, look, this turtle can completely fit inside this box. And that's what I need by a bounding box, a rectangle that can completely hold the bounding box. Now, you might wonder, how do I get this? Well, for rectangular shapes, it's actually quite simple. I'll show you later. But you can also use the turtle.getShape poly to sort of understand the corners of the turtle, and from there we can figure out the bounding box. Actually, a good, nice problem for a general case to think about. But for rectangular shape, it's quite easy, and we'll just go with that. Why is this important? Well, because remember, we want to place the turtle in a way that it entirely comes inside the playing area. So, for example, this is okay because it's fully inside the playing area, but this won't be okay. And what we will do is to make sure that the bounding box is such that it's completely inside. Now, if I can ensure that the bounding box is completely inside, I'm guaranteed to say that the turtle also will be completely inside. And that's exactly what we are going to do. In fact, the idea is not hard at all. All we need to do is that, well, look, remember the playing boundary was, let's say, plus minus 220. So I will give in enough room so that my bounding box can be accommodated. So I will, instead of positioning from the entire minus 220 to plus 220, in fact, I'll do it from minus 220 plus obstacle length, 220 minus obstacle length. So I've reduced on the X as well as on the Y direction. And, that way we can place this turtle. We can be sure that it will always fall inside the bounding box. Here I've already done some part of the work. I've defined obstacle as a new turtle. I've given it shape of square. I have resized this to be, for example, 1/6. Now what this does is that is to extend the turtle in one direction by 6 times. Of course, you can do it differently. I've given it a color of, let's say, olive drab, which is basically, just a color that I've chosen. And I know that since I've expanded this by 6 times in one direction, the length of this turtle is now 120 and height is 20. Now you might wonder where did these numbers come from. Remember, for these foods and let's say the snakehead, we used a square, a regular square without any shaping, and that was 20 cross 20. So now if I'm shaping it by 6 times, it becomes 120. Now this is one way of knowing it, which is quite intuitive. In fact, I can also use, like I said, the t.getShape poly. Now I've created a separate project where I've done the exact same turtle, exact same sizing. And I noticed that the getShape poly, which tells me the vertices for all these 4 corners, is in fact indicating that the turtle expands from 10 to minus 10. So that's 20 on one dimension, 60 to minus 60, which is say 120. So that's why 120 and 20 is. Now to place this turtle, like I said, I'm not going to do it from minus 20 to 20 to 20. In fact, I'm going to give it some room. So say obstacle, let's say length, and 220, say minus obstacle length. Now this will make sure that there is sufficient room from the turtle side to sort of be completely inside this. And I will also do, minus 220, let's say plus obstacle length, obstacle height, HET, and 220, let's say minus obstacle height. So this way we are sure that the obstacle will be inside. In fact, if you are very curious about it, you might notice that I have made it obstacle length and not length by 2. And that's just to ensure that obstacle never goes too much to the corner. So let's just see this working. Notice I get my obstacle placed quite nicely. Obviously nothing will happen right now. You can go on top of it. But no matter what I do, how many times I run this, it is guaranteed to be inside the playing boundary. And that's what the whole. Let's run this once again and notice when I when I ran this once again, notice the turtle is here. In fact, now we are going to move to the next step, which is to make sure that no food falls on top of this obstacle. Right now, remember the food is being placed randomly, so there's a fair chance that the food may just go and fall on top of this. So food is being placed inside this for loop. It can very well go and fall on this obstacle. We do not want this. Let's see how we can avoid it. Very, very interesting idea. In fact, we will use a while loop for placing every food. All we will do is that we'll figure out, look, if the obstacle, if the food's x value and y value is such that it's falling in the obstacle's x value and y value. So we are going to, like I said, to use a while loop. For every food, we'll use a Boolean variable called, let's say, food placed. While the food is not placed, we will generate random numbers as before. If the food is outside the obstacle, we'll say, okay, look, food placed is true, and we can exit this while loop. Question is, how do I determine if the food is placed outside the obstacle? Well, I can look at the x and y coordinates of the food because I'm placing that as a turtle, and I can compare that to the x and y coordinate of the obstacle. If that is, let's say, if absolute value of x, x food minus x obstacle is more than obstacle length, or absolute value of y food minus y obstacle is more than obstacle height, then we know that food is outside and the placement is complete. Now, I really urge you to think carefully about this one. It's very interesting. Think, ask questions. Why are we using abs here? Why are we using greater than here, for example? Why are we using an or here? And try experimenting with these. You will get a very good sense of what goes on and how the code is actually working. Anyway, I'll come back to my code over here. Remember, I'm not going to just place it. So I'm creating the foods through this. So I just create a new Boolean variable called, say, food, placed. I'll set it to say true to start with. Sorry, I'll set it to false to start with because my while loop will be, not food placed. So while not say food placed, if I'm not yet food place the food. So what I do is that I just random place for the food, just like earlier. And I see if my turtle is, so let's say, is the food on the obstacle. So I just check this question, and I do this by saying, like, look, if abs value of, say, food dot x score minus, let's say, obstacle dot x score is, let's say, less than, sorry, it's actually greater than obstacle, let's say, len, or and I do the same thing on the y side. So food dot say y position minus obstacle dot say y position if this is more than the obstacle height. So if either of these conditions is true, I know the food has been placed correctly, and I'm going to set this food placed is equal to true. So sort of ending the loop over here. Now notice that this loop is running, this while loop is running as part of the for loop, which means it's happening for every food. And before the while loop starts, I'm setting the food placed to false, which means this will happen for each food, and each food will get placed away from the obstacle. So here I see that. In fact, this is so an example here. So none of the foods is in fact coming, let's say, near the obstacle. We can do it a few more times to see what's going on. Again, I notice that foods are bound not to come near this, and that's because of this loop. Think through this carefully, and it'll be quite interesting. So forward and see how we can implement the feature of the snake head touching this this obstacle. Like I said, we cannot use t.distance, but let me just demonstrate that to you. What I will do to start with is that I'll say, okay, look, just like I done for a poison, if I were to do the same exact code, let's say for the obstacle, let's see what happens. So I go and, let's say do this. So here it becomes, say, obstacle. Oops. So obstacle, and I just say, look, t dot distance obstacle. If it's less than 20, let me just say, for example, dang, so that it's like it's a collision that happened, right? So now when I run this code, I notice that yes, I'm able to eat the fruits, but I will be able to go very close to the obstacle. In fact, notice I went on the obstacle and nothing happened unless, of course, I go and hit the obstacle right in the middle, in which case, yes, it does detect and it says dang for there. But now the reason this happens is because remember t dot distance tells us distance from the center of the turtle. So what I'm saying is that look, if this is my obstacle, if I put t dot distance as 20, well, my snake head must come within this circle. The center of the snake head must come within the circle for the collision to be detected. Now you might say, okay, why don't I make it larger? But the problem is if I make it larger, then anywhere around this will also be seen as a collision, and that's not fair to the snake that we are using. So really we need to think of a different way. T dot distance, as you just saw, doesn't work. In fact, the solution here also comes from looking at the absolute x and y coordinates. Just like remember, in case of food, we figured out that we've tried to make sure that the food is not getting inside the bounding box. Here, we'll try to figure out if my snake head is getting inside the bounding box, then I'll call that a collision. Now, one way to figure this out would be to look at both the x and y coordinates of the turtle head, the snake head, and let's say the obstacle. If the difference in the x values is less than obstacle length by 2, absolute value of that, and the difference between the y values is less than obstacle height by 2, well, then we know snake is hitting obstacle. Now remember, however, that our snake head itself has a width of 20, so I'm going to add to this 10 to both these limits to make this more robust, because otherwise partial overlaps will still be accepted. So let's do this. Uh, so I get back to my code and I say that, okay, look, instead of doing, let's say the distance, t dot distance, that's not the right metric for me. I'm going to do something similar to what I did for for the food. But here I can say like if t dot x score minus absolute. So here I say absolute value of t dot x score minus obstacle dot x score is, let's say, obstacle length by 2 plus 10, because I want to kind of cover for the overlap. um, or let's say, in fact, this has to be an and I really really urge you to think about this. Why is this an and? Why did we have an or over there? We'll be very happy to discuss. So I just say the same thing, and my t dot y core minus obstacle y core is again less than obstacle height by 2. And since the snakehead also has a width of 20, so I just put half of that, so that is 10 over here. If any of these conditions happen, then the game is getting over and everything else can remain from here, right? Let's see this working. Now, once again, let's say I have my snake here. I go and deliberately hit the obstacle, the game gets over. And that's exactly what we wanted. With this, in fact, this feature is pretty much complete. Obviously, you can further enhance this by giving a different shape to obstacle, making it appear in different orientations, and so on. But, the broad ideas are here, and obviously those can be extended. Before I wrap this up, however, I want to make a very interesting compare and contrast. Remember, in Scratch, if we had done something like this, we would have created a sprite called obstacle, and then we had this very interesting block called touching obstacle. Then I set the game out to true. Now here we are having to do a lot more, because in effect what we are doing is that we are using Python code to create the effect of touching obstacle. And a very interesting exercise here would be to think about how can I generalize this. Remember, in this case, my obstacle length is known to me, obstacle height is known to me, and I've added 10 to the other side because my snake height and length is actually 10. But think about it in a more general setting like Scratch does it. Any two sprites, look at their bounding boxes, look at where they are, and figure out, can we build this touching obstacle, and you'll realize that it's actually quite an interesting piece of code. Some glimpse of it we saw here, right? So do think about this, and this is a pretty interesting point to actually ponder about. If you think this way of learning by building interesting activities, building a basic version, then thinking about enhancements, implementing the enhancements, going through them in a step-by-step manner, if you think this helps you to understand concepts better, look at our website www.wibyte.in, because that's how we learn Python programming, through such fun activities. Take care. Thank you so much. Bye bye.